Do you know that you can calculate derivatives using matrix multiplication, so just via linear algebra? This works for polynomials. We're going to take the derivative map, which is a linear map from polynomials to polynomials, and then we're going to put this map in coordinates so that we can express everything in terms of vectors and matrices. Here, I'm going to restrict myself to polynomials of degree less or equal to 2, so that Rx sub 2, that's what it means, polynomials of degree less or equal to 2, but you could do this for polynomials of degree n. As my basis, I'm going to pick 1x squared, and then we're going to express the derivative map with respect to these bases. To express the derivative in coordinates, what we're doing under the hood is an isomorphism between polynomials of degree less or equal to 2 and R3, such that 1x and x squared map to the canonical basis of R3, and so that the polynomial a plus bx plus cx squared maps to the vector abc. Now, the derivative map is linear, so it will be given in coordinates by a matrix, in this case a 3x3 matrix, whose columns are determined by the image of the basis vectors with respect to the same basis. So the first column will be given by the image of 1. D of 1 is 0, so that tells me that the first vector goes to the 0 vector, so the first column is all zeros. D of x is 1 means that the second vector goes to the first vector under the derivative map, and therefore in coordinates it goes to 1, 0, 0. And d of x squared is 2x, so the third vector goes to twice the second vector, so the third column is 0, 2, 0. Therefore, the derivative map in coordinates sends ABC to the product of that matrix times ABC. So it sends ABC to B to C 0. And now I can take derivatives using matrices. So if I want to take the derivative of 2 plus 3x plus 5x squared, that will be the matrix times the vector 2, 3, 5, which is 3, 10, 0, which back in terms of polynomials is the polynomial 3 plus 10x, which is the derivative of that polynomial. Now, what if I want to use a different basis? What if I want to talk about polynomials centered at 1? So I'm talking about Taylor polynomials centered at 1. Then my basis that I would like to use is 1, x minus 1, x minus 1 squared. So what is the derivative map in terms of that basis? What I need, first of all, is a change of basis matrix from the canonical basis for polynomials to this basis of polynomials centered at 1. To compute the change of basis matrix from the basis B to the basis B prime, I need to express every vector in the basis B in terms of vectors in the basis B prime. So 1 is 1, that vector is in both bases. X is 1 plus x minus 1 in terms of B prime. And x squared, notice that x squared is the same as x minus 1 plus 1 squared. So it is 1 plus 2 times x minus 1 plus x minus 1 squared. So the basis, the change of basis matrix is 1, 0, 0, 1, 1, 0, and 1, 2, 1. By the way, the matrix I will actually need is the change of basis matrix from B prime to B, which is the inverse of this one. And now, since I already know how to express the derivative map with respect to the basis B, to express it in terms of the basis B prime, I have to multiply on the right by the change of basis matrix from B prime to B, which is that inverse, and then on the left by the change of basis matrix from B to B prime, which is the one we computed before. And the punchline of this video is that you get exactly the same matrix because of the chain rule. And the reason is that the chain rule implies that if you have a polynomial that is 2, 3, 5 with respect to the basis 1x x squared, the derivative will have coordinates 3, 10 with respect to that basis. But if the polynomial has coordinates 2, 3, 5 in terms of the basis 1, x minus 1, x minus 1 squared, because of the chain rule, the derivative will also have coordinates 3 and 10.